All right, so for Indicate With Me Part 5, we're going to work on the sort of mathematical correction for offset or taper. And it's nowhere near chronological order of the whole lessons, but here we go. So we've got a piece of material loosely held in the 3-jaw chuck, and it's stuck in the tailstock, held up with a piece of paper. So it's at about center line height both ends. However, this end is substantially too far to this side of the lathe bed, and it to an extent emulates a condition if your tailstock was set over to your side a considerable amount. Likewise, this would also be in this orientation if the bed was twisted horribly, but we're not going to worry about that just yet. We're only going to deal with the premise of the tailstock being offset. So, of course, in my usual fashion, I've got a dial indicator, in this case just a mag back, set right on the tool itself, pointing at approximately center line height of the part. It's set at 0. We'll set our DRO to 0, 0, and then we're going to run the indicator towards the tailstock a certain amount. Doesn't have to be a heck of a lot, but there we go. We've got 20 thousandths of an inch, and just for the sake of it, we'll move that to approximately 5 inches of travel down the bed. So back over there, yeah, we've got about 20 thou that the bar kicks over in 5 inches. Now, how to correct for that? There's a time and place for everything. There's a time and place for the trial and error, and there's a time and place for the mathematical, and I say that this is exactly the right time for mathematical. So what we want to do is figure out how much to move this bar to get its center line parallel with the travel of the carriage, which should be parallel to the long axis of the bed. So we've determined it kicks over about 20 thousandths in 5 inches, and we're going to figure out what that means for a correction down here. So we would then manipulate the adjuster screws on our tailstock and push it back into alignment. You can move the dial indicator anywhere you want for that, reasonably speaking. I mean, the further away from the pivot point you are, the more accuracy you are going to attain. But I find that when I'm indicating in this manner, I just know the distance that I've moved the indicator, and then also know the distance that the indicator now is from its theoretical pivot point, which can be approximated. It doesn't have to be perfect. You can use this exact same methodology to calculate from here to the center of the tailstock, for instance, or perhaps the spindle. I don't see the advantage. The whole idea is to get the part centered up as quickly as possible, and if we don't have to move the indicator to get there, well, let's take advantage of that. So roughly speaking, if we envision, we'll just have to use your imagination there. We'll envision that that piece of paper emulates the condition that exists on this part. That far side is the long axis of the bed. I know it doesn't look very straight, but bear with me here. And this side is where our dial indicator just swept, and it moves up 20 thousandths of an inch over 5 inches. We don't want that. We want it to be on that plane there. So how do we get there? Okay, so we've got the CAD program all fired up here, and we've got Chuck down here. Everybody say hi, Chuck. And we've got the tailstock down here, and we've got the dial indicator here. And we just moved the dial indicator along this plane here, and of course, as we moved along, the reading changed, and there we've got something to work with. We also recorded the dimension that we moved in this direction. So let's plot that. Okay, so there we have our distance that we moved between here's hi Chuck, and there we've got the distance that we moved the dial indicator and how much the reading changed. So that was over the course of 5 inches. So we started our zero reading here, and we ended up here. That, of course, isn't 0 to the center line. It's 0 at that point in space. So let's envision a segment. So there's the same layout, but that in fact is our little tapered wedge. There's the 0 point and there's the 20,000. It doesn't fit at this point in space, and that's why we can't just correct 20 thousandths of an inch and get to the center line. We have to figure out how much more that is to the center line. So this wedge fits very nicely, theoretically, down at that pivot point. So all we have to do is get this down to a common denominator and then figure out where the dial indicator is now that we're done our measurement, and then that's going to get us our distance that we have to move to get from wrong to right. And likewise, we could use that same idea to correct the tailstock. It's just that we take when we reduce that to our common denominator of 1, we then multiply that by the length from the pivot point to the tailstock, and away we go. Looking over here at the lathe, our current measuring point is somewhere around 11 or 11.5 inches. We'll call it 11.2 just to split the difference. It doesn't really matter. I would advocate just get something close, take a first crack at it, indicate it again, and then make the final adjustment, and usually 2 or 3 tries you'll get it perfect. So back over here, we've got the 20 thousandths indicator change over the course of 5 inches. So 0.020 divided by 5, and then we multiply that by 11.2, and that gets us 44.8 thousandths, or 448 10,000ths of an inch. However you want to describe that. Let's call it 45 thou. That'll be good enough. So, as I pointed out before, that taper is of course 20 thousandths over the course of 5 inches. But over here, at that 11.2 inches from the chuck, this dimension from wrong to right is 45 thousandths. Gosh, I hope that made sense. So that when we move this side of the part over that 45 thousandths, that's going to get it in the correct orientation with the bed. And of course, in this case, we're also moving the tailstock to accomplish that. We were going to set up our dial indicator on the actual tailstock itself, which I wouldn't particularly advocate for. You can pick whatever point you want on the tailstock, set up a dial indicator from a fixed location to that object. You could put it at the 3-foot mark, for instance, and that would be that same calculation, the 20 thousandths divided by 5 inches times 36 inches to get you to the end of the tailstock. There's 144 thousandths. So if you were set up with a dial indicator down here trying to crank this over to make the correction to get that in line, you'd be moving 144 thousandths down here. I hope that makes some kind of sense. Don't worry if it doesn't. We'll play with it some more in other videos. And as I mentioned before, seeing as we've already got the dial indicator sitting here, we might as well take advantage of it. There's not a heck of a lot of use, in my opinion, of moving it to a different location. And even better yet, we can cheat and use the direction that this has traveled already and just accentuate it, and then push our part back to 0, and it'll line up. So we said we had to go to 45 thousandths moved over that way to get it corrected. All we have to do is crank this up until it reads 45 thousandths, make whatever correction necessary to the bar, which we're pretending is going to be moving the tailstock over, and we just keep moving the tailstock over until the needle sweeps back down to 0, and there we are. We're there. Of course, you want to check it a couple more times, but it'll 0 up pretty quick, because we have not any easily made adjustment to the height of the tailstock. Just ignore it. Just the one indicator, move the tailstock over, indicate like that, make sure that you stay on center line of the part. It'll be close enough. And of course, this only works if this bar is a cylindrical object. If this bar is an irregular or tapering object, I would suggest, as I mentioned previously, put 2 test diameters that are the band that are the same diameter, you know, at that whatever interval you want. It would be 5 inches in our demonstration case here, or you can account for it mathematically, take your pick. But the everything shown in this video is operating under the assumption that where the pointer starts and stops are the same diameter. The point in between doesn't have to be. It's up to you.